Hello game devs, in this tutorial we are going to create a magnet together, and I want to create a realistic magnet, something like this, and as you see everything is working fine. But before I start, I want to explain you how these magnets are working. As you see here we have an S and N. This fixed joint connects this S and N together, and every magnet have these two parts. And then in the S we have a magnet component that we will create this in our video, and then in the end of this tutorial you are able to create these magnets. So let us start. At first I want to create my magnet object, and I want it to be a cube, okay, and this part will be our N and this part will be our S. Let's create our script. I want to call it magnet. Every magnet have north or south poles, so here I want to know it is a south part or north part. So we create a boolean variable here, and then we will pass this component, our magnet component, to south or north part of our magnet. I will explain it more when we are doing some stuff in Unity. And also I want to create a float variable to define the power of our magnet. Then I want to use trigger stay to know about our other magnets. So I want the magnet component of them, so magnet M is equal to other dot get component magnet, and then if north and M dot north or not north, this means we are in south, and M dot north and not. What it mean? It mean if we are north and the other magnet is north, and this mean if we are south and the other magnet is also south. And we know in this situation these two magnets push each other away, so we have to add some force here. But before that I want to define my rigid body. I call it RB, and I define its value in a start method. And then here I want to add some force. RB add force. What force? This magnet add some force in this direction to this magnet. This direction is this position minus this position. For example, if it is A and it is B, it will be A minus B. So here I want to define my direction, so I want to create an vector tree called direction, and it is equal to our transform dot position minus dot transform dot position. And then I want to normalize my vector because I just want the direction. So now we have our direction. But what about the size of this force? We know that our magnet force decreases with the square of the distance. So I want to define vector 3 and I want to call it force. It is equal to direction divide to vector 3 dot distance transform dot position and M dot position, and we need the square of it, so just do this and multiply it. Okay, and then we just need to multiply our force to power of our magnets, so power and M dot power. Okay, this will be our final force, and then rp dot add force, our force. Okay, and we will need these parts in our else segments, so I want to rewrite them here, and in our else we just have to do this. Okay, let's see what our code is doing. This is our cube. I want to remove this. Here I want to create an empty, call it n, and another empty s. Our n I want to put it here, and our s here. These n and s have to have a rigid body and have to have a fixed joint, and then we want to connect them to our cube. Why we are doing this? Because this n and s have a rigid body, and we are adding some force to them so they can move. But this n and s are parts of our cube, so they have to be connected to our cube. And how we do that? With fixed joints. Okay, let's create some more magnets. A magnet here, a magnet here, and a magnet here. And I don't want to use gravity, so I do this here, and our n and s, and this n and s have to have a magnet. Okay, north, 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 check, and everyone power I want to be, for example, 100, and then I have to uncheck use gravity here, and let's see what we did. Okay, nothing happened. Why? Because our n and s don't have any collider, so we have to create a sphere collider for them. And I want to make it a little bigger, and is trigger checked. Okay, something like this. Okay, let's test our code. Okay, as you see, everything is worked fine, but we have a problem here. What is this problem? Before we do these stuffs here, we have to check that our object is a magnet or not. So here we have to check, is our m null or not? And if it's null, we have to just return. Let's get back to Unity. This n and s, I want to decrease their power just with, for example, 20, and then let's see. So as you see, they are adding some force to each other, but I want to just do this to see that they are working fine or not. Okay, S here and N here, and this one S is here. I want to rotate this cube because I want them to push them away. So let's test, and as you see, they are working right. And if I rotate this, they will pull each other. But it have a problem. And what's that problem? This problem is because of this part of our code, this part. Why? Because when our distance is really low, our force increase a lot, and then some unexpected stuff that happens in our code. So how we can fix this? We can just do something like this. We can move it a little inside of our cube, and also we have to do it with our S and N. Okay, and now let's see. And as you see, now everything is fine. Then I want to add them some gravity, and I want to put them in a plane here. Just make it a little bigger, and now we can see how beautiful is our work. And we can do some beautiful things with these magnets, And for example, we can just rotate this magnet. I just want to copy this position property, and then I want to paste this position, and then I want to make it a little up, and then see how beautiful is our magnets. As you see, everything is work fine, and then they add some force to each other, and some of them just threw away. And we can fix this just with increasing our mass, because our force is really high, so we can just increase our mass, and then we have these beautiful magnets. But as you see, we have this problem, and sometimes our force is really high, and we have to think about it and think how we can fix this. We can fix it with the mathf.minimum. Here we just cut this, and then we write mathf.min this and 0.1. I take mistakes here. This is max, because we want a bigger number here. If this value is less than 0.1, I want to just pass the 0.1, so we have to use max here. And now, as you see, everything is working really good. And when I move this, they are adding some force to each other, and I think it's be set it as for example 0.02. Okay, now let's see, everything is fine in the beginning, and then they are adding a lot of force. I think 5 is better here, so let's see here. And now, as you see, everything is fine, but I want to make it a little nicer, so I want to at first make them a cube like this. Okay, and then I add a fixed joint to one of my cubes, and then I want to connect this cube to this cube. Okay, then I want to do this. Then I want to stick them together. You can do it really easy. Just click on the V key in the keyboard, and then connect them together like this. Okay, then delete S and N here. This will be S and this will be our N, and make it red, and I want to make it blue, and okay, make it blue. And now we have our magnets. Then I want to set them to the center, and then I want to create an empty game object called magnets, and these two cubes will be here. This is our S and this is our N. If I want this to have more power, I just increase this. We have some more powerful magnets. Okay, I think it's enough for this video. I hope you enjoy our magnets, and see you in the next video, and goodbye.